Good evening, everyone. So, we will be actually discussing the physical interpretation of the wave function psi. So, now let's assume that the wave associated with any particle which is in motion, like it can be represented by a complex variable quantity, like in case of psi, which is a function of x, y, z, and t. This is known as the wave function. Now, this is a complex quantity, so you cannot like correlate a direct physical meaning into it, but it is a complex quantity. So from complex numbers we all know that what it can be written as is that it can be written as some a plus ib, as it is a complex quantity where a and b are some real functions of the variables x, y, z, and t, and I we know is root over of -1. Now the complex conjugate can be represented as this of this function of this wave function x, y, z of t psi star, we can say. So that can be written as a minus of ib. Okay, so now if you multiply these two equations, what we would get? It would be x, y, z, t multiplied with phi star of x, y, z, t, where phi star is means the complex conjugate of this wave function phi, as a square plus b square, right? So this is a thing we are getting. Now this quantity in the left hand side can be denoted as modulus of some psi x, y, z, t whole square, which is equal to a square plus b square. Now see that the product of these wave functions phi and phi star is always real and positive. Okay, given that phi is not equal to 0, this would be always greater than or equal to 0, and so its positive root is denoted by this phi of x, y, z, t. That is, the positive root is denoted by modulus of psi x, y, z, t. Okay, so now for the motion of the particle in 3 dimensions, now that this product can be written as the modulus of x, y, z, t whole square, modulus square, is equal to this thing phi into phi star. Okay, so now what we can say in this case is that about the probability density. We will actually determine the probability density, which we can represent as some p as a function of x, y, and z for some particle, for a particle at some point x, y, z in 3D coordinates. Okay, so now the product of now we know that density is some mass per unit volume, and that correlation we can say that the probability density multiplied with the volume element, like the probability density, if we say p of x, y, z multiplied with some volume element d tau. Now d tau is a volume element which can be written as dx into dy into dz. Okay, so the multiplication can be written as phi of x, y, z, t times phi star, that is phi complex conjugate x, y, z, t into t tau, and this can be further written as, from this equation that we have written before, as modulus of psi of x, y, z, t modulus square d tau. Now if you actually do it for a particle in one coordinate, like say x, px, you do in dx, because it would be for one dimension this would be d tau equal to dx only that time. So in 1D you would get this as some phi of x t, phi complex conjugate of x t dx, which is again some function phi xt modulus of this into dx. Now what is this actually? This means this is a probability that this particle that we are dealing with will be found over some small distance dx at position x. Okay, and this phi of x comma t whole square is the probability per unit distance. Okay, I hope it is clear.